Alright, today we're gonna start with inequalities. You will notice that we're gonna be dealing with nonlinear inequalities. Linear inequalities you should be fairly familiar with, okay? Uh, so you're gonna be dealing with polynomials like we have before, polynomials such as x squared minus 2x minus 8 is less than 0. So remember that when you're dealing with inequalities, you won't just be getting one answer. You're going to get a set of values, okay? Sometimes you could get just one value. That is possible, and we'll talk about it in just a second. And sometimes you won't even get a value whatsoever, okay? All right, so here's what you can do to help you out. It says you can use the fact that a polynomial can only change its signs at its zeros. So what that means is, imagine you have the following graph. It's your y-axis, this is your x-axis. And I don't know, let's say you have a graph that's going down in this direction. As soon as you hit the 0 and you go down, you went from positive to negative, correct? So then let's say you turn back up and you went from negative, and as soon as you hit that 0, you're back to positive, right? And let's say you finally turn around and you do one more time, okay? So if I was to ask you, when is this value, I don't know, whatever this function is, when is this function greater than 0? You would say that it's all the values, this entire part here, correct? So from negative infinity to whatever that value is. And then again from here to there, correct? So it's going to be a set of values. It can't just be one value unless there's a special situation, okay? Alright, so how would you actually find out what those values are, okay? Alright, in order for you to do this, you need to find the actual zeros of the polynomial, okay? So we'll start with something easy, which is a quadratic. So you have the following quadratic, x squared minus 2x minus 8, and you're looking for when this is less than 0. What you're going to have to do for the moment is get rid of the less than and substitute an equal sign, okay? You're going to set it equal to 0, and you're going to find the zeros of the polynomial. So if you were to factor this out, it's going to factor out to be what? Good. Now, what you're going to do is you're going to use those numbers to create a number line to help you figure out what intervals this polynomial is less than 0. So what you do is at negative 2, you're going to create like a little barrier. You're going to divide your number line. And at 4, another barrier. That's going to break up your number line into 3 different intervals. Okay? How you're going to figure this out without graphing is you're going to pick a value from each interval and plug it into the equation. So for example, in this middle interval here, I'm going to pick the easiest value there is, which is 0. If you plug in 0 onto the equation, 0 squared minus 2 times 0 minus 8 is negative 8. That's going to be a negative value. That means that everything between negative 2 and negative 4 is going to be below the x-axis. Okay? You can test more values if you want to, but you really don't have to. Because as I showed you in the example above, what happens is as soon as you touch the 0, that's when you change from positive to negative or vice versa. Okay? So that means that at some point at negative 2, you touch that 0 and you went below the x-axis, and then you stayed below the x-axis all the way to 4, and then what do you think is going to happen on the other two? Positive and positive. If you would like to check some actual values, you're welcome to do so. If you were to plug in 5 squared is 25, minus 10, minus 8, that's still going to be positive, right? If you want to do the same thing over here, plug in negative 3 squared is 9, plus 6 minus 8 is positive, okay? So that means when you're writing your answer, we're looking for when this is less than 0. So the only values where this was less than 0 was between negative 2 and 4. So the way you're going to write your answer is negative 2, comma 4. And you're going to, this looks very similar to the way we do domain. Do you guys remember that with domain we use either parentheses or bracket? Okay? It's very important for you to determine which one to use. Would you use parentheses here or would you use brackets? What do you guys think? Parentheses. Why would we use parentheses? Well, more importantly, it has to do with the sign. You only use brackets when that value is included. For example, less than or equal to, or greater than or equal to. But you're looking for something that is less than. If you put -2, you're going to get exactly 0. And I'm not asking you for when it's equal to 0. I'm asking you when it's less than 0. So it's a non-included. So your answer is going to be from -2 to +4. Cool. Alright, one of the things, basically, I summarized everything that it was broken down into steps, but this is the work here. But one of the things I want to let you know is that those numbers that you found are called critical zeros, okay, or critical numbers. So this right here are your critical zeros, or critical numbers, some people call them that. Alright. So let's try some problems. Number 1. What do you think I should do first? Okay. Just like when you're solving a quadratic, you can't solve a quadratic with a number being on the other side. It has to always be equal to, okay? So this becomes x squared minus 4x minus 12 is less than 0. Then you're going to substitute the less than sign for an equal sign, so you can find your critical zeros. And I think you can handle it from here, so try it. Okay, find the critical zeros. And create your number line. Yes. Alright, so when you're done, check your answer. Alright, let's talk about this. You might ask yourself, how did I get those numbers? Because I'm going to assume that some of you guys went ahead and plugged in some values into the beginning equation. And you can't do that. You're going to have to plug in or test your values from this equation right here. Okay? Now, let me show you graphically why you have to do this and why it would still work. Okay? So if you go to your calculator, and I'm going to type the beginning statement, which is x squared. And I'm looking for when it's less than 0, so I'm also going to graph, less than 12. So I'm also going to graph 12. So if you hit graph, I forgot to change my window, so I won't be able to see it. Let me go change my window. Oh, really? I didn't know that. Cool. So I'm going to change my window, and I'm going to make my maximum 15. Alright, so now when you graph this, if you're looking at this graph, I'm looking for when this is less than 0. So I'm looking from when the graph is below that red line, correct? So it would be starting at this point, going all the way to that point, correct? So if you calculate the intersection, for example, here is the curve 1, curve 2, and I'm looking for this intersection, you're going to notice that the value is what? -2, and that's what I got. Okay, and if you calculate the other intersection, I promise you're going to also get the other value that I got, which was 6. And the intersection happens at the value of 6, which is how I got the other one. Okay, so that's what we use the critical zeros. Okay, if you wanted to solve from here, there's really not a way to do it. You're just going to have to test values until you find when it turns positive to negative and negative to positive again. So in other words, you would have to test a lot of values if you didn't have a calculator for you to figure this out. And you wouldn't really know where to start, right? you would kind of start with 0 just to make your life simple, but then you don't know how many points you're going to have to check until it changes points. So that's the reason why we set it equal to 0, find its critical zeros, but remember that when you're testing the values, you have to go back to here, not the very beginning statement. Okay? All right. Go ahead and try number 2. Yes? Well, it depends on what they ask you. This one was less than 0, so yes, because the negative value would be less than 0. If it's greater than 0, then you would be looking for the positive intervals. Okay? So go ahead and try number 2. I give you hints. Use factoring by grouping. And then pause the video and come check your answer. Alright, go ahead and check your answer, please. Alright, there is some unusual situations that you can run into when dealing with inequalities. For example, one of the situations that you can run into is that the solution set to a polynomial inequality can happen to be all real numbers, or from negative infinity to positive infinity. This occurs when the function lies completely above or below the horizontal axis. So, for example, you can have a function, here's your xy axis, that lies completely on the top. So if I'm asking you for when is this greater than 0, when would this be greater than 0? The entire time. Correct? Alright. So B, the other set, can consist of a single one number. For example, pretend I am asking, let's say you have something like this, and let's say this point right here is 1, and let's say I'm asking you when is this less than or equal to 0? It would only be equal to 0 at the value where it touches, correct? So that means that you would only get one answer. So in this case, it would be x equals 1. Okay. You can also have an empty set or no solution. And that would be, for example, I'm going to repeat number A. What if I ask you, when is this equation less than 0? Well, never. Okay. It's an empty set. And last one is D. The solution set can consist of a real number with an exception, such as x cannot 3, which can be written as, for example, like, where would I do that? D. Let's make this 3. If I ask you when is this greater than 0, it will always be greater than 0 except at the value of 3. So that means you get a break at 3, okay? So that's some of the scenarios, unusual scenarios that you can run into, okay? Now, the way to solve this is the exact same way. The only thing is that I recommend that you don't rely on the fact that earlier it was positive, negative, positive, negative, positive, negative. Actually test the values to make sure you don't get something wrong, okay? So let's try number 3. So you have x squared plus 3x plus 10 is greater than 0. Is this factorable? This is not factorable. Ooh, what do you guys suggest I do?
All real numbers.
You can't just say it's all real numbers.
Plus 10 and it goes up. It's quadratic.
Okay. You can use that reasoning. I'll give you that. But let's say you did not see that. Did everyone see what he's saying? Everyone saw what he's saying? Wow. I'm impressed. Anyways, not everyone's going to see it because I'm going to play this video for years. So I'm going to actually answer this, okay? You're going to have to actually, if you can't factor this out, what's the other methods of solving a quadratic? I am not going with the quadratic formula. Do not use the quadratic formula. Complete the square is my best bet for this, okay? So, you will not have a calculator. You can graph them by hand if you wanted to. Sure, okay? So, plus blank equals negative 10 plus blank.
Hey,
Due to showing classes with turn-off, just know that
X squared plus 3x plus 9 over 4 equals negative 10 plus 9 over 4. Right? You remember how to complete the square, right? B divided by 2 and then square it. Okay? So this becomes x plus 3 over 2 squared equals negative 10 plus 9/4. Well, that's the same thing as saying negative 40 over 4. So plus 9, negative 30. Okay? Now, what's going to happen here is, remember that to get rid of a square, you're going to have to take the square root. But what happens? Can you take the square root of a negative number? You can, but it's going to be an imaginary number, and you can't graph those. So now you are left with, now what do I do? Well, this should tell you that this is either all above the x-axis or all below the x-axis. Okay? And now you can use that hint that you guys were telling me earlier. Since this is positive, this is a parabola that is opening up, correct? So that means that the entire parabola is going to be above the x-axis, which means that what should your answer be if you're looking for one? Is this greater than 0? All real numbers, so from negative infinity to positive infinity. Okay? Alright, I want you to try the entire page and then come back and check your answers. Alright, check your answers. Pause the video if needed. Alright, you're also going to be dealing with rational inequalities. Okay? Alright, it's basically the same process, but there's an extra step to it. Okay? Critical numbers are going to be used as well. So you're going to find the zeros of the rational function. Okay? However, rational expression sign changes not only at their zeros, but also at their undefined values. And when I'm talking about their undefined values, what do you think I'm talking about? Asymptotes. Vertical asymptotes. Okay? There could be a sign change. It doesn't have to, but there could be a change at a vertical asymptote. Okay? So, for example, consider the following rational function. You have x minus 5 over x plus 2 is greater than 0. There are two critical numbers in this case. There's a 0, which is, what is a 0 for this one? 5. 5 is a 0. And then there is a vertical asymptote at negative 2. Okay? And those will be the numbers that you would use to create your number line and find out which set of numbers is greater than 0. Okay? So let's try it. Number 1, you have x plus 3 over x minus 2 is greater than 0. Okay, you have a 0 at x equals negative 3. And you have a vertical asymptote at x equals 2. Okay? So you're going to create your number line. Here's negative 3. Here's 2. Alright, if I plug in 0, that will be 3 over negative 2, which is negative. If I plug in 3, 3 plus 3 is 6 over 1, which is positive. And if you plug in negative 4 plus 3 is negative 1 over negative 6, which is positive. So when is this greater than 0? From negative infinity to negative 3. Start. 2. Questions? Good? Alright. That was way too easy. Don't expect anything like that on the test. Expect something more like the following. Okay? Absolutely. Okay? So, consider the inequality 4x plus 5 over x plus 2 is greater than or equal to 3. Before critical numbers can be found, we must subtract 3 from both sides. On the left side, we then find a common denominator and combine the fractions into 1. So in other words, you got to bring everything to one side and make it a one common fraction. Okay? So this becomes 4x plus 5 over x plus 2 minus 3 is greater than or equal to 0. Common denominator is plus 5 over x plus 2 minus 3 times x plus 2 over x plus 2 is greater than or equal to 0. 4x plus 5 over x plus 2 minus 3x plus 6 over x plus 2 is greater than or equal to 0. 4x minus 3x is x. 5 minus 6 is negative 1. And it took you all those steps, but now this looks very similar to the very first example. So your 0 will be located at x equals 1. And you have a vertical asymptote at x equals negative 2. Create your number line. Negative 2, 1. If you plug in 0, 0 minus 1 is negative 1. 0 plus 2 is 2, which means that you have a negative value. If you plug in 2, 2 minus 1 is positive over positive 4, which is positive. If you plug in negative 3, that would be negative over negative, which would be positive. Which means that if you're looking for when this is greater than or equal to 0, what would your answer have to be? Negative infinity all the way to negative 2. And from 1 to infinity. Now, I want to bring your attention, I want to pause this for a second. Remember that x negative equals negative 2 was an asymptote. Can you cross a vertical asymptote? No. So should you use a bracket there? No, this should be a parenthesis. However, can I use a bracket with the 1? Yes. And you should, because we're looking for when it's equal to. And that should be your answer. So be very careful. Do not use brackets. When asymptote is present. Okay, do not use a bracket when the asymptote is present. Alright, so what you're going to do now is on the back of this there is 4 questions. And they're a little difficult, but I want you to try them. So pause the video, work on them, and then come back and check your answers. Alright, check your answers. You will notice that these problems were more difficult, so please take your time to really check what you got. And if you made a mistake, check my work. Homework's at the bottom of the page. Go ahead and do the word problems for homework as well. Okay?
Can we create a bracket?